So this is the beginning of Unit 7. It is the first video for Unit 7. You'll notice it's not called Lesson 7-1. This is my very own lesson. It's called Lesson A. And what we're going to do is work with exponents with the same base. The same base is important. And in case you don't remember what that is, take a look at this first problem here. If we have 3 to the 5th, 3 is the base. 5 is the exponent. So let's follow this logic through. You know that 3 to the 5th equals 3 times 3 times 3 times 3 times 3. 3 times itself 5 times. You also know that 3 to the 3rd is equal to 3 times 3 times 3. I am wondering if there is a quicker way to figure out 3 to the 5th times 3 to the 3rd. Well, let's work through this. We write it out longhand. So here are 5 3's from 3 to the 5th. Here are our 3 3's from 3 to the 3rd, and we're multiplying them together, which means this is the same thing as this. These 5 3's, those 3 3's, which actually gives us 3 to the 8th, doesn't it? Because 1, 2, 3, 4, 5, 6, 7, 8, you know that 3 times itself 8 times is 3 to the 8th. Well, 3 to the 8th is the same thing as 3 to the 5 plus 3, isn't it? 8 is the same thing as 5 plus 3, and that is actually our shortcut. 3 to the 5th times 3 to the 3rd is the same thing as 3 to the 8th. Just add up those exponents. Now, adding the exponents only works when you have the same base and when you are multiplying. Let's do a little practice with that. Alright, I'm going to talk through the first few and then I'll probably turn some music on until we get to the really fun ones at the end. So 8 to the 3rd times 8 to the 6th. Don't you dare pull out your calculators. The base is the same, so leave the 8. 6 plus 3 is 9. 8 to the 9th. Done. 9 squared times 9 to the 6th, same base, and you're multiplying. So leave the base. 6 plus 2 is 8. 9 to the 8th. Done. 7 cubed times 7 to the 4th. The base is the same, and you're multiplying, so you know what to do by now. Let's see what happens with the rest of these. Remember, these should be in your notebook. Take a look at this one. The base is the same. They're being multiplied. You can still add the exponents. Okay? See what happens with this. We've got c to the 4th, c to the 6th. Base is the same. They're being multiplied. So whatever we end up with is going to have c to the 10th. Since this was being multiplied by 5, keep the 5. 5c to the 10th. See what you can do with number 8. Ooh, here's a fun one. Being multiplied, we've got the same base here. What can we combine? X to the 5th and x will become x to the 6th. But don't forget 7 times 8. 56x to the 6th. Oh, and number 10 is big fun. Everything is being multiplied. So everything that is a like base, you can add up. The numbers, you can just multiply like you normally would. Let's see if your answer matches mine. And this is a times 5m, not a 0.5m. All right, I get 240 r to the 7th m to the 3rd. It's fine if you have 240 m to the 3rd r to the 7th. Oops, there we go. It's more traditional to put the number with the higher exponent before, or I should say the variable with the higher exponent before the variable with the lower exponent, and it's traditional for the number to come before the variables. So you just did a crash course on how to multiply number raised to an exponent when the bases are the same. Next question is what about dividing? But before we get there, we need to take a short sidetrack. This is review, but it's important review, so we're going to go through it quickly. You know that 2/4 is the same thing as 1/2. And I want you to think for a second, why? Look at this. 2/4 is the same thing as 2 over 2 times 2. Isn't it? Because 2 times 2 is 4. So you can think of reducing this fraction or simplifying it as being the same thing as crossing out a 2 in the numerator with a 2 in the denominator. That doesn't mean we have a 0 left in the numerator. That means we have a 1 left in the numerator. So that is one way to think about 2/4 becoming 1/2. Similarly, when you have something that looks like this, 4a over 8ab, you can simplify this quite a lot before you have to do anything else with it. And I wrote out every single step, so hopefully this would be crystal clear for you. 4a over 8ab is the same thing as 4a over 4 times 2 times a times b, right? Because 8 is equal to 4 times 2. And once you have things that way, it's pretty easy to see. You can cross out the 4 in the numerator with the 4 in the denominator. You can cross out or cancel out your a's. You are not left with 0 in the numerator. You're left with a 1, and you're left with a 2 and a b. So this whole fraction, 4a over 8ab, is equivalent to 1 over 2b. Kind of like Shakespeare. So back to the question I started with. How can we simplify a division problem like this? The bases are the same. Well, we know that 2 to the 5th is equal to 2 times itself 5 times. We know that 2 to the 3rd is equal to itself, 2 times itself 3 times. And now that we've refreshed our memory with simplifying fractions, think about what we can do with that. We can cross out 3 2's on the numerator and 3 2's on the denominator, which means we are left with simply 2 times 2 over 1, which is the same thing as 2 times 2, which is the same thing as 2 squared, or 4. So your brains are perking along, and you're thinking, 2 squared. What's a simpler way, a faster way to get to 2 squared? Well, 5 minus 3 is the same thing as 2. So once again, very, very simple process. When the bases, I'm going to come back up to the original problem. When the bases are the same and you are dividing, you can subtract the denominator from the numerator. 2 to the 5th over 2 to the 3rd is the exact same thing as 2 squared. And I did write or 4 here. I would leave it as 2 squared when we're doing this kind of work. Don't bother to multiply it out. So, all right, let's get a little bit of practice with dividing these. 3 to the 5th over 3 to the 4th. The base is the same. They're being divided. So this is equal to 3 to the 1st. You don't have to write it as 3 to the 1st. Generally, you just write that as 3. So, y to the 5th over y to the 4th. Same base, they're being divided, so that means keep the y, subtract 4 from 5, you get y to the 1st, which, as I just said, you should write as a y. I'll probably start some music now. See what you can do with these on your own. This is 4 to the 9th and 4 to the 3rd. Here's a fun one. K's with the same base, J's with the same base. What can you do to simplify that? Well, 6 minus 1 is going to give us k to the 5th. 5 minus 2 is going to give us j to the 3rd. Ooh, even more fun. See what you can do. Don't forget to simplify 10 over 5. That says 3 to the 8th. It's not easy to read. Alright, here are the 2 rules that you just need to know. This is your parting thought for today. Your classwork for next class is going to be worksheets that will be in the file box.